Okay. And like I said, the 7-2 notes, for those of you that are at home, they are in the folder for today. Make sure that you access those because your homework assignment for over the weekend will be in this note packet too. So we're going to try and get through as many examples as we can. And then, like I said, the assignment for over the weekend is within that note sheet. All right. It's all related to what's called compound interest. And I guess the way that I can introduce this in kind of a more laid back manner, who likes having money? You like having money, right? Okay, makes sense, right? Everybody likes having money. You would probably want to have more money all the time, right? Pretty easy idea, right? Well, this is a way for your money to gain money. All right. You probably heard money makes money. All right. It's a pretty common, I guess, phrase or something like that. But the more money that you have, the more that you can invest in something, the more money that you put into something, the more it's going to grow. All right. And compound interest is a way in which money grows without you necessarily having to manage it as frequently or as intensely as possible, comparative to maybe like stocks or things like that. Compound interest takes place a lot of times in savings accounts or CDs, which is a certificate of deposit, which acts like a savings account, bonds, certain things like that. Now, you're sitting here at 16, 17, 18 years old. You might not have encountered many of those things on your own yet, but eventually you will. And eventually you want, to be set up for later in life to have a decent amount of money to live off of after, you retire and all that stuff. Again, far-fetched, way further in advance than you're expecting right now. But it does come up and you want to take care of yourself now and your finances now so you're set up for the future. All right. So it's an important idea to understand. It's applicable to your day-to-day lives. Interest, like, not only just takes place in savings, but it also takes place with loans and things like that. Some of you are going away to school and you might want to compare certain loans based off of the interest rates. You want to compare credit cards. If I get charged for something, this credit card is going to take this percentage and compound it, and it's going to be more for me to pay versus maybe another credit card. So these are just some small examples, but examples that you can hopefully relate to, whether it's today or in the future. So it's important for us to kind of understand this concept and what we're doing here. All right. So that's my intro into compound interest. What is it? It's value that's gained on an initial principal, which is just another word for payment, and payments that kind of take place over time. Compound interest has different rates of growth depending on how much it's compounded. And it just takes a percentage of how much money that you have or how much you put in and starts to add on top of that each time. All right. It can be compounded at different intervals as well. So if it's compounded yearly, it happens obviously once a year. If it's compounded semi-annually, how many times does that happen a year? Twice, right? Think about what that prefix semi means. It's kind of cutting it into two, like semicircle or whatever it may be. So it's happening twice a year. Quarterly, how many times does that happen a year? 4 times. Monthly, 12 times. Weekly, 52 times. Daily, 365 times. All right. So we're going to go through a couple examples, understanding, when something is compounded. Is it better to be compounded monthly versus yearly or whatever it may be? But just kind of understanding those different intervals in which it could occur. The compound interest formula is as follows. Now, for those of you that are at home, one thing I did, little mistake on my end, it should be R divided by N. So those of you that aren't here, you have this fixed on your paper. For those of you that are at home, it might say R divided by T in your packet. It was just a typo that I made on my end. So make sure that you change that for each problem. I don't need you to memorize this equation. The more you use it, you might start to kind of pick up on it and not have to, write it down every single time. But I did put it there for you. And it's important for us to recognize, as this relates to what we've talked about so far in class, I'm raising it to 2 variables being multiplied together. So I'm raising it to a power, in which case it is an exponential equation. So this is a real world application of what we've been talking about so far. All right. In these equations, or in this equation, I should say, let's get an idea of what each variable represents. All right. So A is my final amount. All right. So if I put a value in, what's my final amount going to be in the end, whether that's related to savings accounts or loans, whatever it may be. Okay. P is what's called the initial principal or your payment. All right, so that initial down payment, what you put into it. R is the interest rate. All right, and one thing that we want to take into account and make sure that we do each time is changing that rate from a percentage to a decimal. So in order to do that, we move the decimal point 2 places to the left. Okay. So A, final amount, P, the principal, your initial payment, R, the interest rate, N is the number of times that interest is applied. So the amount of times it's being compounded. So like kind of we talked about so far, if it's yearly, my N would be 1. Semi-annually, my N would be 2. Quarterly, my N would be 4. How many times this occurs over a year? And then T is the number of periods that have occurred or the amount of time that has elapsed. So if it's compounded like however many times for 5 years, well, then T would be 5. All right. Any questions for me so far about, where you might see this out in the real world or what some of these different variables stand for? Anything up until this point? Okay. So what we're going to do is go through a couple examples. I'm going to do the first one kind of on my own. One thing I do want to preface this entire lesson with is that if you have a calculator, I would have that out. If you have any kind of resource that you're going to use to help you calculate, like you're using Desmos on your computer or your phone, whatever it may be, just make sure that you have that out because some of these are going to be tricky with some of our decimals and stuff like that. All right. First example, it says an investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in this account, what will be the balance after 15 years? All right. So the first thing that I would want to do if you have a problem like this on your own is to kind of just go through and sift out what numbers relate to which variables, right? And that's kind of what this first bullet point says. Change all the decimals to percent, understand what's going on in the situation, and try and find out what variable is being represented by what number. All right. So an investment account pays 4.2% annual interest. Anytime that you see percent, this is going to be my rate. So my variable for rate is R. And what I want to do is change 4.2% to the decimal, which is 0.042. The way that I do that is just to take the decimal, move it over twice. All right. So R is going to be 0.042. It's compounded monthly. So that means that it's occurring 12 times a year. And the rate at which it's being compounded is the variable N. So I'm going to plug in 12 for N. If $2,500 is invested into this account, so the initial payment or that principal value, the P variable is 2,500. What will be the balance after 15 years? So the time that has elapsed, that 15 will go in for T. Which means the variable that I'm solving for, and it should make sense, what will be the balance? So that future value, bless you, is A. So my final amount after that time is that variable A, which is the one that I'm solving for. Okay. Any questions about how I found those values and why I plugged them in for each variable? Okay. Now all you have to do, plug those numbers into the equation and simplify. So A is my unknown. I'm going to leave that as is. P is my initial payment. So that's 2,500 times 1 plus, and the 1's always going to stay the same. That will never change. It's just a constant within this equation. The rate, which is 0.042, divided by the number of times, which is 12, raised to the N times T, or 12 times 15. Take a second and jot that down. What we need to be aware of, bless you, is the order of operations. So remember PEMDAS and talking about that earlier on in your algebra careers. The order of operations and the way in which we're going to start to solve this or simplify to find our value. You're going to start obviously inside your parentheses. So that's the P part of PEMDAS. And I'm going to start by doing this piece right here. So the rate divided by the number of times it's being compounded. So 0.042 divided by 12. When you do that, you're going to get good 0.0035. My second step is to add 1 to that. So my next line will be 2,500 times 1.0035. And I'm going to do 2 steps at once here and just simplify that exponent. 12 times 15 is 180. The second step, just add 1. First step, divide the rate and the number. Second step, add 1. And then within that step, I also simplified my exponent. Are there any questions as to how I got these values so far? Third step, deal with the exponent now. So don't multiply this number and then raise it to an exponent. Deal with the exponent first. So you have 1.0035 raised to the 180th power. Now in this step, what I would suggest doing is you're going to start to get some crazy decimals. Round it to the nearest thousandth, so 3 decimal places. It's going to give you a little bit more of an accurate depiction of what your actual value should be. So when you do that, you get 1.87554646, whatever. So we're going to round it to the thousandth, so it's 1.876. So 2,500 times 1.876. But when I'm writing my final solution, so now all I have to do, as you can see, is multiply those numbers together. So I'll do 1.876 times 2,500. And I get $4,690. Now that is a whole number. Not every situation will be that way. Bless you. When you are rounding your answers, round it to the hundredths place because that represents cents. Okay. So $4,690.00, or just 4,690. Okay. So that investment account, after 15 years, you put $2,500 into it, now has 4,690. So in this specific example, okay, it's not really a whole lot of money on the grand scheme of things, right? $4,690. It's not going to buy you a house, it's not going to buy you a car, maybe. But imagine if it's now $25,000 and you have $46,000 after 15 years, or it's $250,000. Now you have $469,000 by doing nothing. Just putting it in and letting it do its thing. Right? And there's ways for you to do that. Now, you have to have $250,000 lying around to put away, but you start, like I said, if you build it up and break it down, I should say, and if you put $25,000, well, after 15 years, you just gained $21,000 for doing nothing, right? Being smart with your investments, understanding different interest rates, how many times it's compounded, what value is going to be the best for you, okay? Any questions about that first example? Okay. Another example. So we are going to go to, let's see here. Number 2 here. So it says find the account balance after 20 years if $100 is placed in an account that pays 1.2% interest compounded twice a month. Okay. So now that we've seen one example, let's go through this scenario and see if we can fill out all of our missing variables. All right. So find the account balance after 20 years. So where should I put 20 in for what variable? So not N, for T. So after 20 years, it's the amount of time that has elapsed. That's going to be in for 20 or in for T. N is the amount of times it's compounded given any calendar year. So account balance after 20 years. If $100 is placed in an account, where should I put the 100? P, right? That initial payment. It pays 1.2% interest. So what value and for what variable? So it's going to go for R, but what value is it going to be? What do I plug in? 0.012, right? Remember, you change your percent to a decimal. So 0.012. And it's compounded twice a month. So 24, good. Because we're doing our compounds on an annual basis, which means yearly. So if it happens twice a month and there's 20 or 12 months, it's going to happen 24 times. Which means the variable again that I'm solving for here is A. Well, let's plug these in. I have A is equal to 100 times 1 plus 0.012 divided by 24 raised to the N times T, which is 24 times 20. .012 divided by 24. What's that going to give me? Really small decimal. If I add 1 to it, though, right? So it becomes 1.0005 inside my parentheses. All right. So I did 2 steps at once there. I divided. If you did it on a calculator, you'd get like 5e to the negative 4. That means just 5 zeros. Or 4 zeros. Add 1 to it, you get 1.0005. All right. 24 times 20, what's that? 480. And then what would be my next step? Yeah, how are you? Yeah. Yeah, that's fine. Yeah, no problem. Office 3. Go now. All right. So I'm going to raise that 1.0005 to 480. Again, I'm going to get some kind of crazy decimal. What's that? So it's, sorry, what's your question?
It's like 1 plus 1.
No, so when you do the 0.012 divided by 24, you got the 0.0005. And then you added 1 to it. So I did, yeah, my apologies. So I did 2 steps at once there. When I raise it to 480, I have this decimal. I'm going to round to the thousandths place. So it's going to be 1.2. It's the decimal itself is 1.271172903. I'm going to excuse me. Round that. Couldn't think of the word. To the thousandths place. All right. So 1.271. Multiply that by 100, I get 127.12 for my final answer. Again, rounding to the hundredths, since we're dealing with money, we want to round to the nearest cent. Okay. Again, really small scale example. Put in $100 and 20 years later, it's only gained 27. Was thinking about putting in $100,000. 20 years later, it's $27,000 greater. Some of these CEOs and all these people, they put in $1 million. Now it's $27 million bigger. Right? Any questions about that example? What's that? Stocks. Yeah.
No one don't pay.
It's a lot. It's a lot to, you don't have to wrap your head around that right this second, but it's a lot. Definitely a conversation for another day. We're going to skip over the next example because I want to show you two more within the time period that we have, where we're solving now for maybe a different variable within our equation. All right. So in this example, it says an investment company pays 6% compounded semi-annually. How much should you deposit now to have $10,000 in 5 years? So this is an example. They both, I think they will equally come up at some point, in your lives. But say that you had a goal for yourself, like for, again, this is far-fetched, but for retirement. Say like, I want to have this much money. Well, then how much do you need to put in now in order for that to be a possibility, right? That's a very likely situation to occur at some point in your life, trying to take care of yourself down the line. So an investment company pays 6% interest. All right. So what do I put in for R? What's my actual value? It's 6%. 0.06, right? Just changing it from a decimal or percent to a decimal. So 0.06. Compounded semi-annually. How many times a year does that occur? Twice. Semi-annually occurs twice. Think about, like, I'm sure you've heard semi-annual sale that occurs like fall and spring or whatever. So that happens twice a year. What variable is that going to go in for? For N. Right? The number of times it's compounded. How much should you deposit now? Well, just off of that phrase, what's the variable that I'm solving for? P. Right? So it's going to be a little bit different than what we've done so far. How much should you deposit now to have $10,000 in 5 years? So 10,000 is going in for A, and then 5 is going in for what? T. Good. So let's plug it in, see what we need to invest in order to do that. 10,000 is equal to P on the outside times 1 plus 0.06 divided by 2 raised to the 2 times 5 power, or just 10, right? Eventually. What's 0.06 divided by 2? What's 0.03 plus 1? 1.03. So yes, have the resource, have the calculator, but sometimes you'll be able to do this on your own. 0.06 divided by 2 is 0.03, plus 1 is 1.03. And that's being raised to what power? It's 2 times 5, 10. Okay. One 1.03 raised to the 10th power. It's going to give me P times 1.3439163, whatever. Round it to the nearest thousand. So 1.344. And then what would I need to do on both sides in order to get P by itself, Jake? That's all right. Divide both sides, right, by 1.344. So P, that initial investment, needs to be what in order for me to get $10,000 after 5 years? Good. So $7,440.48. Hopefully you notice a little bit of a trend too between, and this should hopefully make sense, so we're talking about compound interest. The higher the interest rate, the more growth over time. Starting to see a little bit of a trend there. Like in the last example, when we only had 1.2%, well, after 20 years, it was only $27. Whereas here I have 6%, right? And I gain about $2,500 in 5 years. So the higher the interest rate, the more it's going to grow. All right. And that's good for certain things, but bad for other things, right? Like you don't want a high interest on your credit cards, like if you, or your loan, because then if you forget to pay it and they charge that interest, now all of a sudden you have to pay way more and way more and way more. And you start to accumulate debt, which is not good. Okay. But in this situation, like a savings account or whatever it may be, an investment company, better. Last example. All right. And then I'll explain the homework assignment and kind of the expectation for next week. It says your savings account balance is $2,513.45. You opened the account 3 years ago. Interest on the account is compounded weekly at an annual rate of 4.35%. How much did you invest originally? Somebody walk me through. What are my values going to be here? Okay, so let's hold on there. $2,513.45 is A. Somebody different. What's my P value going to be? We don't know that yet, right? That's our unknown. Good. What's R? Somebody else. .0435. N. Jake. 52 because it's compounded weekly. And then how long is this being compounded?
3.
3. Good. Nice. Any questions about how I got those values? All right. Let's plug it in and see what we get. So 2,513.45 is equal to P, which is our unknown value, times 1 plus the rate 0.0435 divided by the number of times it's compounded, which is 52, raised to the 52 times 3 power. Okay. What's the first thing I need to do? So if I'm looking at this equation here, where do I start? Jake? Good. And it's a very, very small decimal. When I add 1 to that, because that's my next step, I get 1.0008. Bless you. And then what's 52 times 3? 156. Good. Okay. Do 1.0008 raised to the 156 power. Does anybody have a calculator on them? What's that number going to be raised to or rounded to the 1,000? 1.133. Good. To finish this problem, what do I have to do on both sides? Divide. And then my final answer is going to be what? So P is equal to so you round up. Yeah, you still round up. 2,218.40. Yeah, so 40 cents. Good. So you put in $2,218.40, and now 3 years later you have $2,500.13, or excuse me, $2,513.45. All right. Any questions about any of those examples? The process itself isn't overly difficult, right? It's just a lot of plugging in values and simplifying. But I think it's a good break from what we've been doing with just kind of doing a process for the sake of doing a process, but not seeing some of the application. So now we're seeing these exponential equations in real time and how they relate to us in several different ways: savings accounts, investment companies, credit cards, things like that. All right. Any questions about that example or anything that we did today in class? Okay. Your homework over the weekend is in this packet. So that's why I said for those of you that are at home, make sure that you access this. Make sure that you change that R, or excuse me, the T that's under there to an N. I did it on all of your papers, but for those of you that are at home, it might not say that right this second. It's just 3 questions. All right. Kind of a variety of what we've seen today. Some solving for A, some solving for P. When you come into class on Monday, we will go over each of those questions, sorry, and then we'll continue a review of compound interest. One thing to keep in mind is that you do not have school on Tuesday because of election day. So we will probably just stop compound interest after Monday and then begin review on Wednesday and Thursday in preparation for just a mini quiz. It's going to be 3 questions just related to sections 7.1 and 7.2. All right. Any questions for me about the assignment or the expectation at all for next week? Okay. With that being said, those of you that are at home, you can go ahead and sign off. Enjoy your weekends. All right. And I will see you all on Monday. Those of you that are here, just wait for the bell to ring, which should be in a couple minutes.